Okay, let's turn to the final discrete probability distribution, and that is the negative binomial distribution. And let's just take a look at that formula. And yeah, it doesn't look too accessible at first sight, but at a closer look, it indeed looks very similar to the binomial distribution. And remember that the prime example for the binomial distribution was the coin flip example. So we asked the question, what's the probability that when you flip a coin 8 times that you get, for example, 5 heads? When it comes to the negative binomial distribution, we asked the question, what's the probability that we observe a certain number of failures before we reach the certain number of successes? So think, for example, about a goalkeeper that has a success probability of saving a penalty of 0.2. So there's a goalkeeper that saves every 5th penalty. And now we want to know what's the probability that the goalkeeper must concede, for example, 3 penalties, doesn't save 3 penalties, before the keeper saves the second. So if you take a look at this formula, there is already an element that looks very familiar. So 1 minus p, that's the failure probability, raised to the number of failures, times the success probability raised to the number of successes. Okay, so that is very similar to the binomial distribution, if actually not identical. Well, in the binomial distribution, the first term, so the binomial again was what's the probability that we have x successes in n trials when the success probability is p. And then we said this is, from n choose x times the success probability raised to the successes times the failure probability raised to the number of failures. Okay, so now let's take a look at this one here. So k is the number of failures, so 3 goals, plus we want to know the second is saved, but then we subtract again 1. Okay, and then we divide over the number of failures, k. So then this term becomes the number of ways to arrange the failures among the successes. And noting that the last trial must be the nth success. So that's when we stop. So technically here we arrange the failures among the successes. Okay. So let's go actually first try and stick with this example here. So the success probability is 0.2, and we want to know what's the probability that a goalkeeper has 3 failures, meaning the goalkeeper concedes 3 goals before he has R equals 2 saved, when the success probability of saving a penalty is 0.2. Okay. So that means at the 5th shot, the goalkeeper needs to save the penalty. That means that is deterministic. That means the other failures need to be distributed around the 4 ways that are remaining. That's why we have here a -1. Okay, so now the formula would be 4. So I'll just write it like this. So this would be from 4, choose 2, times the failure probability is 1/4 raised to the 3 times the success probability. It's a 1/4. It's 4/5.8. So the success probability is 0.2, so that's 1/5, and of course the failure probability is 4/5.8 times 1/5 times 2. Okay, now let's see if we can calculate it in our head. It's probably a borderline case. Okay, let's start with the combinations. Okay, so this is 4 times 3 times 2 times 1. That's not supposed to be an arrow, divided by 2 times 1 times 2 times 1. Okay, so that cancels out, so we have 12 and over 2, so the first term is 6. Okay, so that means there are 6 ways to miss among 4 penalty shoots, or there are basically 6 ways to score in 4 penalty shoots 3 goals. Okay, so here we have 6. So now what is 4/3/5? 4/5 raised to the 3. Okay, that is 4 times 4 is 16, so that's 64 over 5 times 5 is 25, times 5 is 125. Okay, and what is 1/5 squared? 1/5 squared is 1/25. Or it's the same as 5/125. Okay, so now we need to use a calculator, and actually that's not too useful. So now let's see what we get. So we said, okay, this is equal to combine from 4, choose there was a mistake, case the number of failures, so that should be a 3 here, right? So mistake 3. Okay, 4 times 3 times 1 over 3 times 2 times 1 times 1, so that is 4. Okay, there are 4 ways to score 3 goals from a penalty if you have 4 tries, because the 5th must be a miss. Okay, so that's correct. So that was my mistake. So combine 4, 3, so that is 4. Okay, times times, then we have 4 over 5 cubed, which is 64 over 125, 64 over 125 times 1 over 25. Okay, so there's an 8% probability if we calculate it manually, but let's just double check whether this is also the formula that Excel would give us. So in Excel we would use the formula. Let's see what we get when we start with NEC. And there's already NEC binomial distribution. And that's pretty straightforward. The number of failures, 3. Then, comma, the number of successes, 2. The success probability is saving with a probability of 0.2. And we don't want it cumulatively, so that's 0. And now let's see if we get 0.08, which is the same. Okay, so there's still some intuition to it. And let's go to the last slide. And that's just another example. What's the probability that you fail X times before you get to N successes? Okay, that's the general form. For example, what's the probability that you need to flip a coin 5 times before you get 2 heads? Okay, so we just use our formula. NEC bin, we don't have to do it manually anymore. We did it once, it's enough. Equals NEC binomial distribution. And what was the question? What's the probability that you need to coin a flip 5 times? That you need to flip a coin 5 times before you get 2 heads. So that's 5 failures before I get 2 successes, when the success probability is 0.5. And again, I don't want it cumulatively exactly 5 times. And so that's a 0. And that's a probability of 4.68%, or if we round to. Okay, so those are the discrete probability distributions. What's important is that you can apply them very quickly, especially in Excel. So when you have a problem that you know, okay, this is a hypergeometric drawing from a bowl without replacement, this is a binomial, this is a negative binomial, or this is a Poisson. So I hope that this has helped to get a little bit of an overview of the various distributions, but beginning with the next video, we will review again and doing plenty of problem sets. Okay, so let's just stop here and I'll see you when we do the problem sets.